Hello everyone. Today I'm going to discuss about operational level of Etabs. So let us start. Firstly, you have to go for the Etabs. Just open the Etabs, and then after here you have to go for the new model. Just click on new model. Then you will get this model initializations. Okay. So in that you have to go for use built-in setting with. Just click here. And here there are display units. So in display units you have to go for metric SI, that is different. Either you are in Indian code, like that you have to go for the metric SI. Okay, just click here. And still section database. So if you are using Indian, so you have to click here Indian. Either there are different types of code, European code and Russian code already there, but in which code you are following, you are going to design, just you click here, just click Indian. Okay, now this is the steel design code. So in India, the steel design code we generally use IS 800 2007, and different code is there, but in India you are using IS 800 2007. So you have to use IS 800 2007. Just click here. And concrete design code, so in Indian concrete design code is IS 456 2000. Okay, just click OK. Then after here you will have to go for the blank. Either you can go for the grid only, but normally we generally use the blank. So just click on blank, because they are different. Here this is the blank, this is grid only. Suppose you have to create different types of structures here in Etabs, so you have to go for grid only. This is the steel deck, this is the staggered truss, this is the flat slab. So in the case of flat slab we don't use beam, directly slab will come on the column. Okay, so this is the flat slab with perimeter beams. And here we generally use the waffle slab, and generally here two-way or ribbed slab. So different types of structural objects is here. So normally suppose you have to import any types of structure from the AutoCAD, so directly you go for the blank and just click OK, because normally we generally prefer the blank, because first what we do is that we create different types of plan in AutoCAD, and from AutoCAD we generally import to the Etabs. So we generally use the blank. Okay, so these are the, you can see that here this is the model explorer. So here this is the project information is there. Here this is the structural layout, and here this is the properties. So in properties what happen is that you have to go for the material. Just click on material, right click. Here you have to go for add new. When you go for add new, there are some materials will show here. Region, this is the material type, this is the standard, and this is the grade. So region, in which region you are going to construct the structures. So here we are going for India, so just click here India. Okay, material type, there are different types of material. Which type of material you are going to use in your structures? Either here steel, concrete, aluminium, cold formed, rebar, tendon, masonry and other. So generally if you go for the RCC structure, we generally go for the rebar. Okay, don't go for the steel. Okay, this is for the rebar. Steel, when you go for the steel structures only. So if you are go for the RCC structure, reinforced concrete structure, so here you have to go for the material type is rebar. Okay, and standard you will get Indian. And in grade, so if you will use rebar, so there are generally different types of grade of steel. Either this is the mild steel, high yield strength deformed bar, grade 415, that is FE 415. This is FE 500 or this is FE 550. So which type of grade you have to use? Generally we go for the FE 415 and FE 500. So just click FE 415 and OK. And then this is the material type, already showing HYSD 415, and this is material type is rebar. This is the weight per unit volume. Generally you have to take 70. Normally we go for the 76 or 78, like that. Okay, this is the modulus of elasticity, and just click OK only. So see here you have, it's already created. And another also you have to go for same, like go for material, go for add new, and here again one other grade you have to use. So HYSD grade 500, just click here OK. and just click OK. So FE 415 and FE 500 you are going to use in your structures for the analysis and design purpose. Okay, now again you go for the material and go for add new, and here now you have to use for the concrete. So in concrete generally you have to confirm that which type of grade we generally use. It is start from M15. M15 means M generally shows the mix and 15 is the characteristics compressive strength of concrete. So which type of grade of concrete you are generally use? Suppose if we use M15, so M15 the proportion of M15 is how much? That is 1:2:4. So if you are using M20, so it come for the 1:1.5:3. M25 that is 1:1:2, and beyond M25 M30 it is generally come for the design mix. So normally we prefer for the M30 for the design mix, or you can go for M25 also. It's up to you which type of structure you are going to design or analysis. Okay, so here any type of structure grade of concrete you can take, depend upon the types of the structures. Suppose that you are going to construct different very heavy structures like you can say that bridges structure like that. So here you can go for the M20 M40. So normally for the column, for the beam we generally go for the M25. Okay, just click here M25 and just click OK, and here also just click OK. So M25 it's already came, understood? And here you have to see that one thing, just go for the modify and see here, this is the modulus of elasticity. So how it will come? So this is the 5000 into grade of concrete, which type of grade of concrete you are going to use. So here we are generally using M25, so into 25, because the formula is 5000 under root FCK. Okay, so 5000 into 25 into under root means 0.5. So just click here, multiply 0.5. Okay, or just enter OK. So this is the modulus of elasticity for the M25 you are going to use. Just click OK. So already grade M25 is already created. So now when you are going to analyze any type of structures, so here you are going to use HYSD 415 bar, that is FE 415 bar, and FE 500, and concrete is M25. So this is the process to create the material. Now you come for the frame sections. So in frame sections just click, just right click and add new frame property. So here you have to confirm that which type of frame you are going to use. Either you have to go for the RCC, you have to go for the steel, you have to go for the steel composite, or you have to go for the special structures like. So suppose you are using the RCC beam, so just click here. Now this is the property name. Here you have to give some sizes of the beam, like suppose you are going to create beam, so just click B here, just B, and which size of beam you are going to use, because now you don't know which type of beam will be safe. So normally we prefer for 230 into 300 mm. Initially we start for the size of the beam. So here you take 230 into 300 mm size of the beam you are going to use here. So just click here, property name is beam B 230 into 300 mm. Here this is the material. So what you have to use? So here you are going to use M25 grade of concrete. So just click here M25. This is the depth, this is the width. Depth is always greater one. 300 is the depth. So just click here 300, and width is, that is 230. Now you have to go for the reinforcement, that is modify show rebar. Just click here. Here you have to click design only beam, and here longitudinal bar or confinement bar. So in longitudinal bar you are going to use high grade strength of steel, that is HYSD 500, and confinement bar is 415, that is called X bar and Y bar, your X direction and Y direction, this is only, okay. And in the case of beam covered to longitudinal rebar ground group centroid, we generally go for the 60 mm. So just click, already 60 is there. Now just click OK, and here just click OK. So already it's completed. So suppose any type of beam you are going to use, suppose that you are going to use any type of beam, you have to create. So just what you do, that just go for the property. Here you have to use this one, just click here, and now you have to use like this, okay. So this is the, you just click here or see, this is the beam of size is 230 into 300 mm you are going to use. So this is the process, okay. Now just go for the delete, just click here, it's already deleted. Now again you have to create the column. So just again go for the frame sections, right click, add new frame property. Here just click concrete, and here you have to go for the column. We are taking 300 into 300 mm size we are taking initially. In material you have to go for the M25 grade of concrete, and here also this is 300 and this is also 300. Now you go for the reinforcement, that is modify show rebar, just click here. Now here you have to go for the column, just click already here. Now longitudinal bar and confinement bar. So in longitudinal bar you have to go for HYSD 500 and confinement bar is 415. This will be as usual, just click OK. See what is this, I am just showing you modify show rebar, just click, see here number of longitudinal bar along 3 direction face, it is 3. What is 3? See 1 2 3 rebar. If you change, suppose you are going to change 5, just click here, see what happened, 1 2 3 4 5, matlab 5 bar you are going to provide in these directions of the column. And again here see how much in the number of longitudinal bar along 2 direction face, how much, 5 means 1 2 3 4 5. Suppose in these directions in the column you have to provide more rebar, so just change here, okay. Instead of this you take 10 and click OK. See what, 10 rebar you are going to use. So this is the process, you have to be confirm how many number of bars you are going to use, like that, okay. This is the initial process. After when you go for the analysis and design, automatically it will be coming, depend upon the percentage of reinforcement and how much area of reinforcement we will be getting after analysis and design. According to that we generally provide the number of bars and diameter of the size of the column and all. But initially you have to be initiate with some number of bars, like that, okay. So here we are taking see 5 only. So just click 5. So number of, in X direction also we are going to provide 5, and Y direction also we are going to provide 5. Just click OK. So you have been created frame sections and all. Now you have to go for the slab sections. So in slab sections just click add new slab sections, and here you have to provide the slab. So normally slab we generally provide 150 mm, means 100 to 150 mm thickness we generally provide. So here we are taking 150 mm. And slab material you have to go for the grade of concrete, here you take M25, and here slab, so thickness is 150 mm. Just click OK. Here in modeling type you have to go for shell thin, okay, because there are 3 options: shell thin, shell thick and membrane. So different conditions. Suppose in the case of normal slab we go for the shell thin. Shell thick we generally use where you are going to provide the raft foundation and all. And membrane generally used for the staircase slab, okay. So normal building like for the room and for the kitchen, for the hall, we generally go for the shell thin only and 150 mm thickness. Just click OK. So it's created already slab. Again you have to create for the stair slab. So just click here, write ST slab, just ST slab, and a slab material is M25, and here thickness generally we use 200 mm. So just HC slab right here 200 mm thickness of the slab. In the case of stair, the minimum thickness of slab we generally take 200 mm. So here we are taking 200 mm, and here modeling type you have to go for the membrane, and here use special one-way load distribution. Just click OK and right click OK. So it's created like OK. And in building also we go for the overhead water tank slab also. So just click add new slab sections, and right here OHT, that is called overhead tank slab. So it's also we take 200 mm thickness of the slab. For that it will be M25, it will be shell thin only. Just click here 200 mm and OK. So it's already created. OK. Now we come for the wall sections. What is wall sections? Suppose in structure you are going to provide any lift. So here we generally provide the shear wall. Shear wall is that RCC wall. So in that case you have to create here. So in wall section just click here, add new wall sections, and here write shear wall of, generally we take 200 mm shear wall thickness, and property type you have to go for the specified wall material. Click M25 grade of concrete, and it will be shell thin only. Thickness just go for the 200 mm because here you created 200 mm, and click OK. So it's already created. Understood? Now if you want to create any beam, so what you will do, just click here. See, this is the draw beam column. Okay, you have to create any beam, and to just click here, and here you have to check property type is which type of beam you are going to use. So we generally use 213 300. So just click and just click one like that. So it's created beam. Okay. Suppose you have to create any column, to just click column here, and this is the option for the column, quick draw column. Click here, and here property type, go for property and check. This is the column 300 300. Click here, and just click here one column here, one column here, like that. So you have to create. This is the process for creating the column. Now you come for the slab, like, so in that you have to make one more beam like slab. Okay, so what we do, just we are creating one normally for like okay. So now you have to create this. We generally create one slab like, and here you have to provide the slab. So just go for the, this is the options for, if there is a rectangular slab then you go for these options. If there is a zigzag like that, you go for the this option to create the slab. So here just click slab, here it will come to go for the property, and we created slab 150 mm. So click here and just go for here and create like this. So it's already created slab. This is the 2D, and this is, it's showing the 3D. Okay, so see, here we provide column, here we provide column. So this is the column. Again you want to provide the column in these sections, go here, click and go for the column of this sections and this sections. See, already created. So this is the 2D, this is the 3D of this. So now suppose we want to provide a shear wall. So what you do, see, this is the option for the shear wall. Just click here, and here you go for the shear wall of this one, and auto pair spandrel, just click yes only, yes. And suppose you want to provide here shear wall. Okay, so just click here. See, already shear wall has been created. So where we provide the shear wall, you don't provide the beam. So just click and delete that beam. So it will be like this. So this is the shear wall. So this is the process for the operational process of, I just discussed some things about. This is the initial stages, the person who want to start the Etabs. So this is the initial process. Firstly operational level should be very good in any software. Any softwares, I'm not talking about Etabs only. In any softwares like AutoCAD, Etabs, safe, SAP 2000s, if you discuss with the Revit architectures, if you discuss with the CSI bridge softwares, Midas Civil, Procon, Stat Pro, whatsoever software you are going to use in analysis and design. So normally operation level is very good, and concept level is also should be. If you don't know the operational level, how we have to be operational the things and all, to know how will start. So this is the major, and this is the only I discuss something about, not it is the full operational level of this. There are different operational level also in Etabs. So I just discuss basic things, how we create the materials, how we create the frame sections. In that we create a beam, we have to create the columns, so how we have to create the slab, how we create the wall section and all. So I hope you enjoyed my lectures, and in next day we'll come with another lecture. Okay, thank you so much.